So, triangle proportionality theorems, part 2. I'm just going to call it triangle proportionality part 2. So you don't need to draw this. I'm just going to draw this on a little note card. Again, you don't need to draw this. Let's say I've got some triangle. And I've got some line that goes through it in a way that it's parallel to one of the sides of that triangle. So in this diagram, I've got this side on the left parallel to that line. Well, it divides those two sides proportionally. So if I call these A, B, C, and D, the proportion comes almost like this is a large triangle and a little triangle. It comes starting from the corner that they both share. The proportion here, the way I've got it labeled, would be B over A is equal to C over D. Y'all please get your heads up. No matter how the triangle is oriented, that proportion sticks. Okay? The thing is, for number 1, we've got a little bit of extra information. We've got this segment parallel to this segment, and we want to know this little piece right here, but the proportion that I set up is not going to include the number 6 at all. Let me zoom in on that. I'm going to start with 8 over x. Is equal to 4 over 2. Do we all feel pretty comfortable about where I got the 2 from? What this is saying is this much of that side of the triangle is 4, but the entire side is 6. But I don't want 6. I need just this little piece right here. So if this much is 4 and the whole thing is 6, then the rest of it must be 2 down here. Sound fair? Now when we cross multiply, x times 4 is 4x. 8 times 2 is 16. Divide both sides by 4. You get x equals 4. Feeling okay so far? Okay, number 2, there's a problem with it. We can get the answer, but to actually get the answer, we need to get something else first. So, the proportion that I set up is going to be 5 over 4 equals, well, it would be this over 8. The problem is that's not really x. What I want is the entire segment here of that triangle. But if I set up this proportion, I'm just going to get this much. Are we cool with the fact that we're just going to call this x, get the answer, and then add x and 8 to get the final overall side length? Is that okay? And if you don't want to call it x, you can call it something else. You can call it y or z. But we're going to cross multiply 4x equals 40. Divide both sides by 4. X equals 10. Is my final answer 10?
No.
What is my final answer?
18.
18. How are we feeling about that so far? We didn't really want the 10, but we needed it to actually answer the question. We'll give you a second to get caught up if you need. Okay. Jumping down to number 3, it's even a little bit more difficult. I've got one side length of that triangle that's split, that's 15, and then the entire triangle is 18. So how much is this down here?
Number 3.
Just the number 3. And then I want to find this length. Just that little bit right there. So we can call that question mark x. Y'all with me so far? So I'm going to set up the proportion 15 over 3 equals, oh man, hold up a second. This part right here is not 42. I know it's over x. What do I put for that other long piece?
Maybe another x?
Well, I don't want to call it another x because that would imply that they're the same length.
Oh.
So I've got another unknown here. But I do have some information that'll help. The problem is that nobody likes it. If the entire side length is 42 and this much is x, the rest of it is 42 minus that much of x, right?
Yeah.
Okay, so guess what we had to call this? 42 minus x. 15 over 3 equals 42 minus x over x. Okay, who wants to solve this? One person wants to solve this exactly like it's written. We can do that. But I asked you who wants to solve this because we don't have to do it this way. There's an easier way, a much easier way. Setting it up is really difficult. But let's go ahead and solve it out the long way. Ooh, 3 times 42 minus x, 126, is that right? So we've got 126 minus 3x equals 15x. Add 3x to both sides, 126 equals 18x. Divide both sides by 18, you get 7. We'll talk about that shortcut here in just a little bit. But do me a favor and try number 4. Number 4 is going to be performed the same way as number 3. So we want just this little baby piece right here, right? The whole thing is 12. Whenever I set up the proportion, I've got to say the little baby x over the rest of that. But I don't know what the rest of that is. It's just the whole 12 minus this little x. So 12 minus x. Okay. I'm not going to ask you, how are you feeling about this? Because honestly, these types of questions for me are a thumbs down. Right? Because the proportion is just set up to try to scare you a little bit. But I promised you a shortcut, so are you ready for it? Okay, reason proportionally with this figure. If this entire side length is 6, and this entire side length is 12, isn't that just double 6? If it's proportional, these sides must follow that same proportion. So this side length of 5, 10 must be over here. This side length that we reasoned out 1, this must be 2. Does that feel okay? Now, I was going to show you that with the other one, but 18 to 42 is multiplying by 7/3, and I just thought 7/3 was kind of a gross fraction to show that with. But 3 times 7/3, boom, is 7. Okay, oops, is 7. Now you can see the boom. 3 times 7/3 is 7. Does that feel a little bit better? Now, if you like setting up those equations, solving equations is good for the soul, but if you're like doing a little speed challenge, reasoning proportionally might help you out here. Okay, 5 and 6. Do those look like triangles? No, it looks like 3 parallel lines crossed by 2 transversals. But the side splitter's theorem still works here. We actually have a triangle that's kind of hidden. Oh no, the triangle is crossed by 2 transversals, but they're still parallel to that side. So instead of being cut into 2 proportional pieces on each side, it's cut into 3. But it don't matter. The 15 divided by the 6 is equal to the unknown piece divided by 8. We feel good about x equals 20. Okay, again, that proportional stuff that I just told you about works here. What do you multiply 6 by to get 8? It's a gross decimal, or a gross fraction. To find it out, 8 divided by 6 gives you 1.3 repeating, or 4/3. So the multiplier from 6 up to 8 is 4/3. So the multiplier from 15 up to x should also be 4/3. Hey, look at that. It's the 20 we got. Let's do that one more time. We've got this beautiful set of 3 parallel lines cut by 2 transversals. It makes this triangular figure. Okay. If this much of that piece is 8, and all of this is 24, how much is this? 16. Hey, do you notice a relationship between 8 and 16?
They double.
Hey, it's doubled. Well, if we're being proportional here, what do you think I do with the 10? Double it to get 20. Hey, what do you think the answer is?
20. Oh, wait, no.
30. Aren't proportions great? Because instead, we would have had to set up 16 over 8 equals something, x over 10, and then cross-multiplied to get 8x equals 160. Divide both sides by 8. You get x equals 20. So that's 20, so the whole thing is 30. Proportions. We love them. Right? Questions on the side splitter theorem? Okay, flip your paper over to the angle bisector theorem. So here's a triangle with an angle bisector. I know that because this little line has the two little angle markers. They both have one line. If they both had two lines, that still means that they're congruent. So if I call this A, B, C, and D, the ratio of A divided by B is proportional to C divided by D. So you've got both the leg lengths on top and both of their corresponding little cut pieces from that third side on the bottom. But for quite a few of these, I see no reason to set up a proportion and cross multiply. I mean, you can. That's not a problem. But you don't need to. Y'all, this is wonderful stuff. Stay with me. Come on. Number 7. I would set up 8 over 6 equals x over 3. But hey, 3 and 6, what relationship do we have there? Okay. 3 doubles up to 6, so what number doubles up to 8? 4. I mean, that's pretty sweet, right? You could also say that 8 over 6 reduces down to 4 over 3. Next one, if this much on the bottom is 8, how much is the rest of this? 10. That's not the answer that we actually wanted. It's just some information that's going to be useful. Because is there a relationship between 8 and 16?
16 is divided by 2, which will give you 8.
Yeah. So what divided by 2 will give me 10?
Wait, I thought we multiplied since the smaller numbers on the bottom and the bigger numbers on there.
Okay. The relationship between this leg and this little piece is 16 divided by 2 is 8. So the relationship of this piece, of this leg divided by this piece, should be the same thing. What is half of what is 10? Or 8 times 2 is 16, so 10 times 2 is 20. Now, if this is throwing you for a loop, you can set up proportions. It's fine. 8 divided by 6 is equal to x divided by 3. Or for number 8, 16 divided by 8. Is equal to x divided by 10. Either way, you're going to end up with 4 and 20. I just saw a couple of y'all say 420. Get your minds out of the, I guess not gutter, out of the dispensary. Number 9. Little bit less obvious. Okay? So the proportion that I would set up is 15 over 6 equals 10 over, Just be careful. We can call this x if we want. But once we get x, make sure you say x and 6 added together gives us our final answer. Are we all cool on that? So 15x equals 60. Divide both sides by 15, you get x equals 4. So what's my final answer?
10.
10. This much is the 6 and the 4 added together. Can I show you a proportion ratio type of thing that would give you that answer a little bit more quickly, maybe, if you don't like cross multiplying? Okay. 15 over 6, that's a fraction that can be reduced down to 5 over 2. Right? Well, I know this seems a little bit dumb. Why would we want to unreduce a fraction? But if I double the top and bottom, I get 10 over 4 equals 10 over x. Well, now that the tops are the same, the bottoms have to be the same as well. X is 4. Just another way to think proportionally about that, okay? This is another one of those something minus x questions. Okay? So, 12, 16, I don't have enough information here to think proportionally, so I'm going to have to set up the proportion with that formula. So, I want this much. It's called x right now, so I'll say 12 over x equals 16 over what? Go for it.
21 minus x.
21 minus x. So yeah, I don't have enough information here to really think proportionally. I mean, I kind of do, but I still would have to solve a gross equation. So let's just go ahead and leave it at the gross equation that it is and cross multiply. 12 times 21 is 252. minus 12x equals 16x. Add 12x to both sides. You get 252 equals 28x. Divide both sides by 28. You get x equals 9. Is that my answer, or is there any more funny business I need to do?
Huh?
Is my answer 9, or is there any more funny business that I need to take care of?
Isn't it supposed to just be 9 since there's only that one question mark?
Yep, it's just 9. The only time I need to do any more funny business is if it was asking for an entire side length. Like number 9. Okay, 2 examples and then we're done. 11 and 12. Uh-oh, these are more of those diagrams so that they're trying to scare you by saying, hey, 3 lines intersect at the same point, this point right here, in such a special way that the overall angle created by this line and that line is bisected by the 3rd line. And then there's some 4th line just hanging out over here that's crossing them. Guess what? It still makes the angle bisector theorem. You know what else is so sweet about this? Are we all cool that the answer is just 20?
Yeah.
Because if this little piece of the 3rd side is 6, double that to get 12, this little piece of the other half of the 3rd side, or other part of the 3rd side is 10, double that to get 20. I love ratios, love proportions, they're amazing. Number 12, same sort of deal. Now, in reality, I want this entire piece up here, but to find it, I need to add 10 and x together. Here's my sneaky little math stuff going on, okay? 35 over x is equal to 14 over 10. Can I simplify 14 over 10?
Yeah.
What does that simplify to or reduce to?
7/5.
7 over 5. Okay, can I unreduce it now and multiply the top and bottom of this fraction by 5?
Yeah.
I mean, sure. Why would I do that? Because I can. 7 times 5 is 35. On the bottom, 5 times 5 is 25. As long as you multiply the top and bottom of a fraction by the same number, you're not actually changing the value of that fraction. All of those are going to divide out to the same thing.
Do you have to do that?
Do I have to do it? No. But now I have 35 equals 35 on top. So the bottom has to be 20. 25. So if this much is 25, what's the entire side length? 35. Hey, fun other fact, doesn't that make that an isosceles triangle? Yeah. 35, 35, 14. That's an isosceles triangle. Love that for us. Go ahead and put that paper in your binder, please. The way some of y'all are looking at me with such ire, everyone was like, isn't that fun? Isosceles triangle just hidden in there?